Hey guys, welcome back to our Day 10 content. We are on page 134, and we're continuing our probability study looking at an interesting facet called complementary counting. And complementary counting is easiest to understand reading these lines here. So it's often easiest to compute the probability of what we do not want. And then in order to get what we do want, we subtract it from 1. Which, remember, 1 is the same thing as like your 100%. So sometimes problems are really difficult in that, let's say I'm looking at soccer games. And I'm going to be playing 15 games in the next, however many weeks. And I say, what is the probability that I win at least 2 games? Now, notice the difficult part of this probability problem is that if I want to see what are the chances I win at least 2 games, that means I could win 2, 3, 4, all the way to 15. So it seems like it would be burdensome to have to calculate all those probabilities separately and then put them together to get your final answer, right? By adding the probabilities. Same kind of thing as probability that I pick a Snickers bar out of my Halloween candy or a lollipop, where you add those together. But this seems like it would be really, really hard. So the way that you would solve it is take 100%, and subtract the probability that you win no games, as well as subtract the probability that you win 1 game. And those two probabilities are much easier to calculate, and so this problem becomes a lot simpler. Generally, the vocabulary I look for to signify that this is a useful strategy is something where it talks about like at least, or it just seems like that there's going to be a whole lot of different things that I have to calculate, and I don't want to get overwhelmed, and I want to look for a way to simplify the problem. So let's look at an actual example from our book. The chance of rain for each of the next 5 days is 25%. So, rain, 25%. What is the probability that it will rain at least once? See, notice that at least, right? At least once in the next 5 days. So we want to think about what is the chances it doesn't rain at all. Because rather than calculating probability it rains once, twice, 3, 4, 5 days, right? And what's tricky about that is you could have it be like rain, no, 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 no. You could have no rain, no, no, no. Right? You have all the different orders of everything, so it gets pretty difficult as you go into the minutia of that. It's much easier to say, okay, what are the chances we get no rain at all, and take that away from the 100%. So we're going to do 1 minus probability of no rain. So probability that you have 0 days of rain, and we are told that it is 25% chance of rain. So the chances that we don't have rain, no rain, would be 75%, right? So I'm going to represent 75% as 3/4 and 25% as 1/4, just to make it easier. So 3/4, right, chance of no rain, 3/4, 3/4. And I'm just doing this just so you guys can see the 5 days. You can also just do it as 3/4 to the 5th power. So what I will be calculating is 1 minus 3/4 to the 5th power. So I'm going to pull up my calculator, and I'm going to do, in parentheses, 3/4, caret 5th power. And then it looks like it about a 23.7 chance, right? So not unlikely. It looks like almost about a 1/4 chance. And we're going to do 1 minus, I'm going to do second answer, which is that negative sign down below. And that's a good trick for those of you guys who have graphing calculators like this. So doing the second negative sign has a little answer above in yellow, right? Notice the keys have in yellow or green, whatever command you would be giving it if you press the green or yellow button first. So it looks like 76.27 if I round. 0.7627, I'm going to round it to that. right? Because it was 269, which is the same thing as 76.27% chance that that will happen. Okay, so that's like the basic idea of how to do these kind of problems, right? And this is actually really similar to my example of soccer games. So I like that those are pretty similar. That way you can help keep it in the back of your mind of what the problems typically have as a structure. And then let's see, we have example 2. And example 2 is actually the last problem. These topics that we're doing today are very special cases. So this one is like really, really easy to see because otherwise you get super overwhelmed. The previous example of using combinations, you kind of get used to it with practice, I think. Anytime you're doing groups where there's not a specific order, that's kind of your signal. So these probability problems that we're doing today are just kind of special cases, and we're practicing what signals us that we need to use this special case technique. Okay, so why don't you try number 2. Go ahead and pause the video and work through number 2, read the problem, make sure you understand what it's looking for. You can look back at number 1 if you get stuck, right? You can unpause the video if you get stuck and you want to like hear me walk through the answer, but try and do it on your own as best you can before you unpause. Okay, so if you look on the left side over here, I've got my worked out solution. So we have 9 letters left, 2 of them are U's and 7 of them are not U's. We want to pick 4 tiles and we want to know what are the chances we get at least 1 U, right? We could have 1 U or 2 U's. And this one's a little bit, less cumbersome. It's not like you have to do a bunch of different cases. It's only really 1 and 2. However, it's more complex because of thinking about like the order that you pick the letters and how you factor that in and out. So it's a little bit easier just to do what are the chances you'll get no U's at all and subtract it from 1, right? And that's kind of what I've set up over here. And so probability of no U's is there are 7 tiles that are not U. Remember 7 of 9. And then 7 ninths is, pick the first something other than a U. And then you're down to 6 non-U's, 5, 4, and remember the total goes down each time by 1 as well. That simplifies to, I've got the same thing over here, 5/18. When you do 1 minus 5/18, remember you can think of 1 as 18/18. It becomes 13/18. There's actually a method too. If you saw it this way, you might have. Some of my students really prefer to do probability problems using combinations because it comes a little bit more easily to them. So you also could do probability of 0 U's as 7 choose 4, right? 7 non-U's, I'm choosing 4 of them, and the 2 U's choose none, over 9 choose 4. So it kind of connects nicely to our last video about how to use combinations strategically when doing grouping. And then once you get your 5/18, right, same thing as over here, you would do 1 minus 5/18 and get 13/18 as your final answer. So that is our last example for our complementary counting. And the last video to get ready for tomorrow goes over a couple of different mini topics. Today's kind of like our mini topic day, really. And we're talking about geometric probabilities to begin. It's got some diagrams on page 137. So go ahead and go to page 137 in the course packet, and we're going to be walking through the examples on this page. I'll see you guys in the last video.